Yo, good day. Okay, what do we have here? Today we are going to go over an Ampeg VT-22 or V-4. It's the same amp. One's a combo version of VT-22. The V-4 is just the head version. It's the same exact amp. And more importantly, what we're going to go through here, or the focus, is going to be just about strictly the focus on the grounding structure in these amps. I've done some videos about grounding structures in Ampegs before, and this one deserves a specific special one on its own. So if you're interested in that, hopefully you're going to have, or I'm going to make a very clear and detailed, definitive overview of the grounding structure in these amps. Okay, so let's just get into the specifics a little bit about this particular model of Ampeg. There's many VT-22 and particularly even more V-4 models over the years. This particular one is from about 1977, a little later. Some discerning features of this particular version compared to other versions is some obvious things to see immediately. There are 4 tone shaping switches in the amp. Later models and maybe even earlier models, you may only see 2. And in this one in particular, the big discerning factor, because there are some with 4, but this one has a master volume in addition to the 2 preamp channel volume knobs. That's a big way to tell which version this is. This one, if you look, there is a schematic on the top of the amp. Took a picture of it. It's a little cruddy here and there, but actually it's mostly clear. And you can see the dates, let's show it later maybe, of when this schematic was created. Now, unlike Fenders, a lot of times they pretty much put the correct ones on the amps, and in this case it is. And this one is dated from 6/13/1977, so June 13th, 1977. I've already opened the amp, and inside there, the one pot, I can easily see the time, the date stamp on it is from the 31st week of 1977. So this is an older one. Now, let's discuss why this is hopefully going to be a definitive video on the grounding structure, because, very importantly, this is a rare amp from the point of view that it is virtually, and I'm almost certain 100%, it could be 99.9% untouched inside the circuit, inside this chassis from the day that it left the factory. It's rarer and rarer will you ever see an amp like this in one of these amps that has not been touched. And unfortunately, what ends up happening on these amps, because of the confusing or misleading, or some people just can't get their heads around the grounding structure, when they do things such as recap or otherwise modify this amp or fix things in the amp, they lose the correct grounding structure. They connect things incorrectly. Well, or less desirably, and certainly not in the way they were originally connected in the amp. We're going to be able to look inside here, and we're going to take a very close look at that, exactly where the day it left the factory, how the grounding was put together. So there you go. Anything else you need to know about this amp will have to be in other videos. We're going to concentrate on the grounding. Of course, as we're going through and looking inside, there will be some other things we'll probably point out here and there, but let's concentrate on that grounding because it's pretty key. Okay, so let's do a quick broad overview of the grounding structure in these amps. By the way, here's the schematic, and the reverb tank, which I've already detached, is on the backside of the top panel. So I'm not going to get into a lot of the other stuff in the amp, so let's just concentrate on the grounding. These are the reverb lines that have been disconnected already. So if we take a high up view across what we have in the amp is, if we start from the back end, and we're going to come back to this, this is where we're going to start actually from the rear to the beginning. You'll notice if you take a look at these two jacks, they are insulated from the chassis. There is no ground connection at these are the speaker output jacks. One is an external speaker, one is the actual regular, which you would tie the first cabinet to. There is a impedance selector switch. However, what you have under here is there is a ground wire coming from the jacks. There has to be some sort of ground wire that is actually attached to, there's a capacitor can here. And once again, in a quick overview, if you take a look at that capacitor can, it is not electrically connected to the chassis. Not at this point, at least. You see there is some sort of fiber or phenolic board here, spacer, that the capacitor can is attached to. So the ground lugs, typically that would be attached and somehow soldered or otherwise electrically connected to the chassis or not. The line from the output jack, the ground line, goes to what is the common 0 reference volt or low reference volt, which would normally be to the chassis. However, if we follow a line, we follow that it is not connected to the chassis. A line goes out, it connects with the rest of the circuit somewhere along here. We'll get into the details of that, and so on. And that is connected to the board. Nowhere on this board is it connected directly to the chassis. What you will find then is where it is connected to ground, to the chassis, to the ground safety, is at the input jacks. These lines here, and I'll show that in a little bit. One other confusing thing about this, and where I was not sure, the other amp that I have that I'm working on, the other VT-22, same vintage, it was recapped. And they didn't replace it with a cap can, they did it with discrete components, and they really did a number on where it was grounded. I could not follow, could not figure out, knowing that these amps are generally a bus structure through the amp to one single point tied to the chassis, to the ground. I knew that something was up because that was not how they were structured. That is the reason why I actually bought this amp. I bought this amp with the hopes that it was going to be largely untouched, and my dreams came true when I saw this, because if you look at it, it is completely untouched. That I could then follow the grounding scheme as it was originally supposedly created out of the factory. So that's why I did that. And what I found is actually a better amp than, well, I shouldn't say better amp, it's in better condition. I had to do a lot of work on the other amp just to clean it up. At any rate, so let's take that's the general thing, but to confuse things, this board here separately has a little bit of a different grounding structure, and that's part of what my confusion was. I wasn't sure where things came together, and we'll get into that in a minute. Okay, let's see if we can get a real close look at what's going on here at the speaker output jacks. These two jacks, this one and this one, are actually, they have isolation washers that keep them from being connected to the chassis electrically. So they are not connected. However, of course, they need to be grounded. You can see there's a ground. This is where the ground would come in. This is the sleeve, and it's connected to the ground point on the other jack. This is the main jack you would plug into. And you'll see that ground is then connected to the ground lug, one of the ground lugs of the capacitor can here. Let's ignore that can, what that can is for, which filter can that is, or which filter capacitors. But so I said, okay, now where is the ground going? There's no other grounds anywhere connected to the chassis. This is the impedance selector switch. But if you look, there is another wire connected to this lug. It can be followed through the amp. There it is there. There's no connection. It comes back out. Let's see if I can move this on the fly. It's heading all the way over to the other side of the amp. That wire, let's see, where are you? That wire is coming across here, that's this wire. And if you look, it is tied in to one of the cathodes of the output tubes. And so far we haven't seen the chassis. So there's several other lines, however, connected to this point. This is pin 8 on the one of the output tubes. Here are the 4 output tubes here. The 7027s, which are similar to 6L6s. And if we follow this then, we see there's one line that comes up to a potentiometer. Now I'm going to jump ahead here. This potentiometer is actually a hum balance, because if you look, these lines are going to the filaments, each side of the filament chain through the amp. So what's happening here, to what will be a ground point, but we need to follow it to see where it's connected to the chassis. This is a hum balance pot that moves that ground point from one side to the other in the filament tab. Okay, but we're still not seeing a direct ground connection. We follow the other wire that's coming from this output tube. Let me move this out of the way. You'll see it connects to each of the output tube's cathodes. All right, so where is the ground? All right, if you follow again, here are all the grounds that are tied to pin 8s that are chained to that point that's coming in from all the way over by the output jacks. But if you look here, there's another mystery wire that's connected. And you're like, okay, now we're further down the chain. And if we follow that line, let's see if I can get a better shot. All right, let's switch the camera to the other side of the amp. Let's see if you can find a perspective here. We're coming from the output tubes to the front of the amp. We're following this line, which seems to be the continuation of what is the ground bus. And if we look, this line comes around underneath the board and connects to the board at this point. All right, so now we have to figure out what this point is. And if we look on the schematic, I don't know if I can easily show this. That point is, let's see, can we see where that is? If you look, we see this diode here, and we also see the standby switch. This is the ground line in the schematic. So what we're seeing here is this point is connected in through what is basically the ground, the ground contact throughout this board. So far it has not touched the chassis, nevertheless. And if you can see here, at this point we have a diode. In here, from this junction to this junction, is actually part of the standby switch, or this is the standby switch here. If we look at the standby switch, I don't know if we can see it from where that camera angle is. This is connected, the standby is connected into this point here. Is that it? Yep. Is connected into that point and will connect this side of the circuit, which includes the rectifier. By the way, these are the famous or infamous flyback resistors. I've got to check those. A lot of times they go bad and the amp won't operate, but that's a different discussion. So what we're looking at then, let me see if I can get a better shot. So just to review all of that, effectively what we're saying is all the way from this end of the amp, there is no ground connection. It's connected up, so this is connected through to the point where the cathodes are connected to ground, which are then follow that wire and are connected onto this circuit board. At no point during what we looked at is there any connection to the chassis for ground reference. By the way, if you take a look here, you can see here, this may be the one spot I am not 100% sure if it's original. This looks like the original, an original 3-prong chassis grounded cord. There is an extra line here, which is a little confusing because all the solder points that there is an accessory, a grounded accessory plug, a 3-prong accessory plug, look to be like original solder joints. At any rate, but let's go back. So now what we've got to do to analyze or take a look at the ground structure in the amp is what is going on in this board. I'm going to jump way ahead here. You can follow every point in this circuit on the schematic where any component is connected to ground, such as cathode resistors, or for that matter, in the bridge rectifier that's over here. You know, one side is connected to ground. If we follow all of these, they are connected to this one line. The only place from this board that is connected to the ground is, let's see if I can do it on the fly here, are the input jacks. So if you follow the lines from the input jacks, the shield lines are connected to the board to that ground that goes throughout this board, are connected from the input jacks. So a couple things there. One is, it's really important that on these amps, that the input jack connected, the connection of the input jack on the amp, on the front of the amp, is good, is clean. You know, you need to make sure these connections to this amp are nice and clean, because that is carrying all of the ground connection, which goes back to the 3-prong cord, which is the safety ground that's connected to the chassis. All right, so that's in effect, that's the easy part of this amp. Let's go over a couple other things when it pertains to ground. One is this smaller board here. This drove me nuts before I saw this amp and the amp that I was working on. Let's look at this on its own. There are several points. There are 3 tubes that are connected to this. There are cathodes that need to be grounded. There are obviously components through in any circuit that need to be connected to ground. And if we follow where those grounds are, if we look, an obvious point where you can see is grounded is a shield wire. This is for the reverb tank. Shield wire here. If we follow this, there is a ground line that's connected to this board, and interestingly it is connected to this point, this tab, which is connected to a post. What's interesting is if you take a look at that post, and we'll flip over the amp and I'll show that how these are connected. The post itself is connected to a spot that's actually painted. It doesn't look like a great connection, but if you test this and you test it compared to whether or not there's continuity to the chassis, it's there. So this board here, all the connections are connected to ground through this point. They are not connected through that other structure that I described that comes all the way from the output tubes all the way to the input jacks. If you look through the circuit and what's on this board, it seems as though there shouldn't be any ground loops. A ground loop is when you have one component that is connected to ground in 2 different places, and there's a ground loop that ends up current can flow between those points. There is one point, you know what, let me turn the camera around, hold on. Okay, we're looking on the other side of the amp now. We're looking at this board. We're focusing our attention on this jack. This is the foot switch jack for the reverb. Why I bring that up is because there is a connection to the chassis here. This is not a grounded, isolated jack. And there is also a ground wire that connects up through into this point on this board. So what we have here is a potential for potentially a ground loop. We have this jack is connected to ground at two different points. Well, first of all, there shouldn't be too much current going through that jack. I don't know. Let's take a look. How does that jack function? Essentially, how that jack functions. See, I don't know if it can be shown here. That foot switch jack is here. We have that connected to ground, as we can see there. It's connected to ground twice. It's connected to the shield for the cord that's going to the reverb. And it looks like it is the return of the signal to the recovery tube for the reverb. So it's the signal that's coming from the actual reverb tank that is then shown to the recovery tube to then go apply some gain so that it can be applied to the rest of the circuit. So what is happening here when the foot switch is engaged, in other words connected to ground, then what it is, the signal is going to ground. When it's not connected to ground, when it's lifted, it doesn't come into play. It's actually hanging outside the circuit. So I guess there is no concern for a ground loop there, so that's why that's done. So just looking through the rest of the circuit, as I reviewed the circuit, it doesn't seem that any of these components are connected to ground anywhere but here. And in this case, it would be through this post. All right, so actually the ground structure in this amp, there's 2 points at which components are connected to ground. One is, as we saw, through most of the amp, and that is to the input jack. And the other is the components on this board. Okay, let's go to something a little different. It's sort of related. It is related to ground. Ground comes into play, but it's important to point out on these amps the structure of the filter caps, particularly the first 2 nodes. So let me rearrange this camera here, see if we can get a better shot. Okay, before we look at the amp, let's take a look at the schematic. Let's see what the structure is for the filter capacitors. We have here is our bridge rectifier that's providing the high point, is the A node voltage. Now, where is that? Let's look at the filtering that's going on for that A node. We have what looks to be, at this point, which is the A node, we have a 100 microfarad capacitor at 450 volts that is connected in series to another 100 microfarad capacitor at 450 volts. Basically, these are a series connection for a 50 volt, 900 volt specified, or that can handle 900 volts at this point. Around that, we have these two, these are actually voltage divider resistors. Some people think they are there to drain the capacitors. They're not. They're actually to ensure that the voltage drop across each of these is even, so that one isn't handling a greater voltage than the other, that it's split evenly. So what is this rectangle, though? This rectangle represents, these 2 rectangles represent the capacitor can. It's a combined 2 capacitors in a single can. I'm going to show those to you in a minute.
So we have another one, we have one can here and we have one can here. But each can is 100 microfarads and 40 microfarads. Interesting. And one can to the other is connected in series in the 100s. But there's no connection on this 40. Why is that? Well, let's take a look. First, let's take a look at the capacitors themselves. So here are those two capacitor cans. And what we have is we have a one can that has 100 microfarad capacitor here at this terminal. I don't know if you can see it on behind that wire. And this terminal is, as you can see, is not connected. It's a 40 microfarad capacitor. Here is the other 100 behind this resistor. And here's another 40. Now this resistor and this resistor are those 100K 2-watt resistors that are in series, in parallel in series with the two 100 microfarad capacitors. So what we have is, we have from the A node, we have a connection from the bridge rectifier to this node in the can capacitor. This capacitor is then from the negative connection, which is here on the capacitor can, that's this point, is connected, you go across, it is connected to the 100 microfarad capacitor in this can. So what we have is 100 to 100 in series. We have the series resistors. And to this point is interesting, is the ground connected to the ground structure in the amp. And if we follow this line, we follow that line, we shall see that is connected up through the board at a point along this ground structure that we looked at before. As a matter of fact, it's right, see if I get it, it's connected right here. So that's what's going on with that. So what's going on with these two 40? The next node, the B node, this is the A node, there is a dropping resistor, R55, and to the B node we have the next set of capacitors. There are two, you can see in the schematic, there are two 40 microfarad capacitors in series. There are no voltage divider resistors around these, but one of them happens to be in a can, a capacitor can, and the other one is somewhere else. So let's see if we can find that. Well, lift up a little bit. We know that this is the 40, and now we know that this side is actually the 40 because that's the 100 that's in series. So this 40 microfarad capacitor is connected up through here, and if you look, it is connected to this discrete component, a 40 microfarad capacitor at 450 volts. It is in series. This is the negative side. The positive side is then connected to the board here to supply the screen with a filtered voltage. You follow it up here. Ran out of schematic there, but if you follow it, and this schematic, if we go from, no, it's not that schematic either. The full schematic, thank you. If we take the full schematic and we go from that B node and we follow it up, we see that it's supplying all of the screen resistors, which are somewhere around here in the circuit. But you say to yourself, well, that's why is, if you needed two 40 microfarad capacitors in series, and you've got one in each of those cans, why aren't you using those in series? Well, here's the problem. since the 100 microfarad capacitors, one in each can, are connected in series supplying the voltage for the A, this bottom half of the capacitor can is not at zero. It's halfway at that 545 volts. This cannot be shared in series with two other items. In other words, you couldn't connect this to this because it would be sharing a voltage. It actually would be part of that circuit. So what they did was, and there may be other ways of doing this, is they used one of the canisters, the capacitor cans, is connected to the ground structure. So this would be always 0 volts. So it wouldn't be a different voltage. So that could be used in series with a discrete capacitor to supply the voltage for the B node. Otherwise, you'd be mixing voltages between the B and A node, and I'm not going to think through what could happen there. Could there be other ways of doing this? I don't know. But certainly what's important to realize is that at no point, if you are replacing these capacitor cans with discrete components, you cannot ground them to the chassis somewhere around here. You can see that these two cans are isolated from the chassis. There is no connection here with the ground structure of these. And otherwise, and also since they are in series, this cannot be connected to the chassis at all, because this point here in this canister is not 0 volts. This is halfway through the two 100 volt series capacitors. It is at about, help me with the math, 250 and 20, 270, about 270 volts. This point here is about 270 volts. It'd be a real problem if that was connected to the chassis. Things would go up in smoke. This one arguably could be connected to the chassis, but that would create a ground loop. What you want is the rest of the structure is to follow the structure of the rest of this amp. Okay, so there it is. Let's just quickly go back to the other side of the amp. Okay, it was a little tough to show it with the camera to get in there, so I'm doing this on the fly. Just to go back and see if we can see if there's a better way of seeing how this is connected at the far end here. All these lines, this canister here is for the preamp nodes in the circuit. And if I were to show that, this canister at this end are these three capacitors. Now, this capacitor is the common ground is at 0 volts. It's not as if any of these are in series. However, you can see that this is, as we discussed before, is not connected to the chassis anywhere until we follow it all the way through the end, back up onto this board, and back to the input jacks is where that is connected. But what's important is, you know what, let me shut off the camera and get a different view here to show you what's going on with those canisters on the outside. Okay, here's the back end of the amp, and what we see here, it's important to note, is that here are the capacitor cans. This is the one with the 3 preamp tubes. This is the one with the 100 microfarad and 40 microfarad in each of these. These are in series, or half of the components are in series, but you'll see that they are covered. They are insulated because, as we said before, the actual outside of this canister, the common ground of this one, I believe, is actually at 270 volts. It's in series with this. The outside of the canister of this one, I believe, is at 0 volts. Arguably, this doesn't need to be covered, nor does this, but it's, if they're there and they're available, that's what's going to happen. Now, when I work on this amp, these capacitors are going to be changed. And I think what I'm going to end up doing is I'm going to replace them with direct replacements that will work for the amp. I will have to cover them with these. I will remove these sleeves. They usually are glued in some sort of tar. Actually, you can see they're kind of loose, the capacitors themselves. But I might have to cut them, remove them, place them on the replacement capacitors, and tape them up. Label them on the outside too. So that's that. Let me shut off the camera. I'm going to take off the back of this panel, so you can see that this is actually where the ground comes in. The one of these posts, I forget which end, I'd have to take a look where it's sitting, is the ground for this particular board. So anyway, actually, you know what? For the discussion of the grounding system, I don't have to take these off. I'm going to do that anyway, but I don't think it's going to be in this video. So there it is. Hopefully in the future, when someone has one of these amps and it's been jacked up to some degree or another by someone replacing capacitors or doing other work on it and botching up what should be the original grounding structure, because the grounding structure works very well on these amps when it is held true. So hopefully this video, because I could not find anywhere on the internet close enough or good enough pictures that I could see how these were wired, and certainly no video. A little bit of a rambling video. Perhaps I'll make another one. I'm not going to modify this. I am going to replace these exact components. So this amp will stay intact, at least the way it's wired. And I could make a better video at some point if some people make some comments and give me some pointers how to do it. All right, thanks.